this is Simon Cushing, and I want to demonstrate a program I wrote in my sabbatical in order to demonstrate the rules used in logic proofs so that my students can practice using them. I wrote it using a program called Visual Studio, specifically Visual Basic. This is the web page where you can download it. This is through the University of Michigan, so I got it for free. And this is what happens when you start up Visual Studio. Okay, here is the program. I'm going to start the program. And this is what Visual Studio looks like. And this is the code that I wrote. I wrote all of this, and I had to learn how to write it. And let me tell you, it was a pain in the neck. The program is far from finished. There are bugs to iron out, and I haven't finished all of the 19 rules. In particular, the rules of equivalence are extra difficult, as we shall see. But let's see what it looks like at the moment. So I'll start the program. The first thing it does is it tells you what to do. Enter your premises into the big box that's going to pop up in a second. So let's do that. So here's the big box, and I'm going to paste something I prepared earlier. But you see how easy this would be to type in. So I made it so that you could type in your logic just using easily available symbols. So a greater than symbol represents if then. But I also wanted it to tidy it up so that it looks nice and it looks like logical symbolization is supposed to look. So that was the first thing I wrote. And when you click the go button, it does that. And it also numbers each line. So this now becomes the first few lines of a proof. Next thing is to apply the rules of inference and equivalence, and that's what it's asking me to do now. So enter a rule, press enter, and then the line number or numbers it applies to. So okay. Now I know that the first thing I can do is Modus Ponens, which is affirming the antecedent. This says if A then not B, and this says we've got A. Put them together and it should give us not B. So I'll say MP for Modus Ponens, and then it capitalizes it when I press enter. The first premise is going to be line 1. The second premise is going to be line 4. When I press that, it tells me, first of all, this is what's on line 1, and it goes through what's on line 1 and highlights what is the main logical connective in that line. In this case, it's the if-then. Here, there is no logical connective, so it just highlights the proposition. And then here is what I will get if I apply Modus Ponens, and it's not B. Do I want that? If I don't want that, I'll press discard. But if I do want that, I press add to proof. So it adds it on its new line, and it tells you got it by Modus Ponens 1/4. This is exactly what a logical proof looks like. Numbers, the propositions, and how you arrived at the propositions. Okay, I'm going to use that new not B with line 2. And this means or, which in logic is called the disjunction. So I'm going to do disjunctive syllogism, and I'm going to apply it to lines 2 and 5. Again, it tells me that the main connective is the or, and on this line it's the tilde, and it's B or not C, and it's not B, so it is not C by disjunctive syllogism. So I'm going to add that to the proof. Then I'm going to use that to do modus tollens on this line, which is denying the consequent. So if this, then C, it's not C, so it should give me the negation of that. So modus tollens, MT, line 3 and 6. Again, now notice it went through and it knew that anything in parentheses is not going to be the main connective, so it highlighted that. That was a particularly hard piece of coding to get it to work out what the main connective is. And it's going to give me tilde D and E. So let's add that to the proof. And that's essentially how it works. I haven't done I haven't done all of the rules of equivalence. I will just demonstrate one of them, which is double negation. Now, double negation, the reason why rules of equivalence are particularly hard to code is because they can apply to parts of lines. So there's many more choices you can get. So if I do double negation, say to line 3, I'm sorry, double negation to line 3, I get many choices. So notice line 3 looks like this, and you can do double negation to what's in parentheses. You can do it to, first of all, you can do it to the whole thing. Then you can do it to what's in parentheses. Then you can do it to D. Then you can do it to not E. And then you can do it to not C. So I get to choose which of those. So in other words, if you type in double negation, there's not just one thing that could result. So I had to get it to open up a whole new option to choose which one you want. So let's say we want that, and then it puts it there, and we add it to the proof. So that's the program, and that's one of the things I did with my sabbatical in fall 2019.